multiplying and dividing rational expressions. So in this presentation, what we want to do is we want to talk about how we can actually simplify an expression such that we see two fractions being multiplied by each other. But the only catch is going to be our fractions are not going to be numerical based. They're going to have algebraic expressions in both the numerator and the denominator. But let's start off revisiting the key concept and looking at what can happen just with numbers. So behind here I have an example. And I'm only going to give you 10 seconds to try to figure it out. So get ready, no calculators. Ready, set, go. Multiply 35 over 27 times 18 over 20. If you have to, you can pause the presentation if you need to. 3, 2, 1. All right, time's up. Believe it or not, the expectation would be that you have this value multiplied together already. Now, I would agree that if you try to do the property of multiplication that says we multiply numerator times numerator to get a value and denominator times denominator to get a value, that probably took you a little bit of time to go ahead and try to figure out what the answer is. Because 27 times 20 is a big number, 540. 35 times 18, another big number. And then we have to simplify. So, what would be a faster way to do this? Well, the most efficient way to do this is actually to envision how to make the fractions smaller. And we can do so by looking at their factors. Case in point, 35 is 7 and 5. 20 is 4 and 5. These 5s reduce. 27 is 3 times 9. 18 is 2 times 9. These 9s reduce. Furthermore, this 2 reduces with this 4 to produce a 2. So this big expression simplifies down to 7/6. But it's a lot easier and more efficient if we look at reducing the factors. And that's the key concept. When multiplying fractions, we're allowed to reduce the factors that are being multiplied with common factors in numerator and denominator. Now let's put this into action with some examples. We're going to use that same concept, but now just instead of having numbers, we have numbers along with variables and some exponents. At this time, you should be able to go ahead and make a prediction on these, but you can either pause or follow along as I work through. If I look at this first example, what I'm going to do is, what's jumping out at me right off the bat is big 27 and that 3 right there. 3 goes into 27 9 times. And I like the fact that 4 goes evenly into 8 2 times. So I know right off the bat, my final product is going to have a 9 halves. I can further look, x's reduce, and in the second fraction, I have an x squared, which reduces with an x. So that leaves me with an x in the numerator. Now, from there, the y's, I have a y left over and a y squared, which means I'll have a y left over in the denominator. So there's many different ways you could have went through simplifying, but that's how I kind of chunked that one. If I look at this second one, nothing's going into each other evenly because the 3 and the 6 are on quote-unquote the same level. They're both in the numerator. So one of the things I see here is the 6 and the 8 can be reduced by a factor of 2, which gives me a 3 and a 4. Now, just to show an alternative strategy, what I'm going to do now is I'm going to kind of just focus in on the first fraction. So I'm just going to cover this up. I'm going to focus in on this first fraction. I see x cubed over x will be x squared. Y over y squared is going to be y. Now keep in mind, we already said the number is going to be 3/4. Now I cover up that first fraction. I have x squared over x cubed, which will result in an x in the denominator, and I still have a y in the numerator. Now, as I'm looking at this, I see I'm not fully simplified yet because I see x's in both. the numerator and denominator along with y's. So I can reduce the y's and simplify the x's, that way there's just one x up in the numerator. So sometimes I simplify everything as one big fraction. Sometimes I separate into two smaller fractions. Oops. But now let's go on to this final example. In the final example, we have something significantly different in the fact that we have division. So what I have to remember is dividing by anything is the same thing as multiplying by it. It's reciprocal. So my first thing I'm going to do is I'm going to switch this expression to multiplying by the reciprocal. Now, we've got a lot going on here again, so I'm going to try to baby step it a little bit. I'm going to go ahead and work with this first fraction. And working the first fraction, I'm just going to leave the numbers alone. I see I'm going to end up with x to the 6th, y squared. Here, I can simplify the numbers by a factor of 2. So that's going to give me 6 and 11. This would be x to the 4th, and this is going to be a y squared. Now I'm going to go ahead and combine these two fractions together. I see I have a factor of 11. So now I can go ahead and say 24. I have x to the 6th over x to the 4th, which is going to be x squared, y squared times y squared, y to the 4th, all over 5. So again, you can either do it all at one time, just make sure you are careful with your work, or you can kind of chunk it down and do little steps by step. Either way, they all end up with the same result, keeping in mind when you see division, rewrite it as multiplying